Hello, this is Mr. Waterman, and we're starting Chapter 4 with applying triangle sum properties. First off, we've got classifying triangles. We're going to classify them using two different dimensions. First, we're going to talk about the sides, and we're also going to classify triangles by the angles, the sizes of the angles they have. So first off, and you're going to need to copy this into your notes. So we have classifying angles by sides. We have three different classifications. First one, scalene triangle. That's when all three sides are different. So we would say it has no congruent sides. An isosceles triangle has at least two congruent sides. So this triangle in the example is shown as having these two longer sides as being congruent. So it has at least two congruent sides. So it's isosceles. Third classification, an equilateral triangle, that's when all three sides of the triangle are congruent. And so equilateral, the root of the word is equa, which means equal, and lateral means side, so equal sides. Next classification is classifying triangles by angles, and we have four different types. First one is an acute triangle. That's a triangle that has three acute angles. So acute angles, again, are angles whose measure is less than 90 degrees. Okay? So all three of the angles in this triangle must be less than 90 degrees. They're acute triangles. All acute angles, so it's called an acute triangle. Next triangle is one that is real popular. You're probably familiar with it. A right triangle has one right angle. Third type, an obtuse triangle. That has one angle that's an obtuse angle. That means its measure is greater than 90 degrees. One angle whose measure is greater than 90 degrees is an obtuse triangle. And then we have a special triangle called an equiangular. That means all the angles have equal measures. Three congruent angles, called an equiangular triangle. So let's see if we can apply this. We're going to come over here to this example. It says classify the triangle in the gate shown in the diagram by measuring its sides and angles. Okay, so if I had you doing this in the book or on a piece of paper, we'd have you measure these sides. Side AD and DC are not the same length. You can tell that AD is the shortest side on this triangle and DC is longer than AD. Additionally, we have an angle marked as a right angle. So you may know from earlier classes that we call the side opposite the right angle the hypotenuse of a triangle, and that's always the longest side of a right triangle. Okay? So we know now that all three of these sides are different. So we would classify this triangle by sides as a scalene triangle. I have the answer written there. So it's a scalene triangle. And we already determined that there's one right angle, so we'd call this a right scalene triangle. Next example, we're going to utilize first theorem from chapter 4, which we want you to copy into your notes. So the measure of the exterior angle of a triangle is equal to the sum of the measures of the remote interior angles of the triangle. So a couple things to clarify. First of all, an exterior angle is formed when you take one of the sides of the triangle and extend it out. So this side EG, I've extended it out through point D. All right, and then the angle that's formed between what we just extended and the side EF would be called an exterior angle. It's on the outside of the triangle, or exterior. It also mentioned remote exterior angles or remote interior angles. Those are the ones that are all the way across the triangle, so the 80 and the X degrees. Go ahead and watch part B of 4.1 for the rest of this example.